Hello everyone. Our topic for today presentation is air quality monitoring system. Basically, we have built IoT based air quality monitoring system device which we can set up at our home, and we can see pollutants in air in graphical form, as well as we can download PPT PDF report on your mobile. What are gas sensor? Gas sensor are device that detect specific gas in air and measure their concentration level. They are used in variety of applications such as environmental monitoring, industrial process control, and safety system. This is activity diagram of our project. So data is sent by hardware to Firebase, and from Firebase to backend server, and we are fetching it in our front end, and we are displaying it in form of graph and location. Working of project is like our sensor sends the area and send data via Node MCU to Firebase in real time. The data is stored in Firebase real-time database. To filter the data, we have made a custom Firebase API that filters the data using epoch. Once it is done, the user has two options to select. He can see real-time data of all sensors in graph or PDF format. And we have also specified a trigger value. So when the trigger value match to the value of sensor, then it automatically send a message to mobile number and email of user. And for SMS, we have used Quillo and NodeMailer for email. We can also generate report with date and time, and also instantly available using specific time and date. We use a Google API to track data showing the exact location where the device is situated. Our solution, IoT based air pollution monitoring system, monitor the air quality, that is, it measures the number of harmful gases present in air like CO2, smoke, ethanol, O3, VOC over web server using the internet. System also display temperature and humidity. It can be installed anywhere, particularly in industry and house where the amount of harmful gas present is considerably high. Our technology stack of our project is, for front end we have used React.js, HighChat for graphical representation, and Google Map for location. And for backend, we have used Express, Node.js, Firebase function, and real-time Firebase database API.
So we have used the certain types of gas sensors in our project. So let's see one by one sensor. So first is Arduino Mega 22560, and this is used for writing, compiling, and uploading the code into the Arduino board. This unit comes with USB interface, so as a USB cable can be used to connect the device with the computer, through which we can transfer Arduino program. Next is Node MCU. Node MCU is an open source software and hardware development environment built around an inexpensive system on a chip, which is called ESP8266, and it can connect the object and let the data transfer using Wi-Fi protocol. And here are given some input voltage is 7, the range is 7 and 12 volt, and the operating voltage is 3.3 volt, and the flash memory size is 4 MB, and the clock speed is 80 megahertz. Next is MQ131 sensor. This sensor is used to detect the low concentration ozone gas. Next sensor is MQ135. This sensor is used for the detection of gases like ammonia, sulfur, benzene, carbon dioxide, and other harmful gases and smoke. And application is this sensor is used for the domestic gas alarm, and the detection range is 10 to 1000 ppm. Next is Neo 6 GPS module. This is used to detect the accurate location. SGP SGP30 SGP30 sensor is used to detect the wide range of volatile organic compounds and hydrogen, which is intended for indoor air quality monitoring. DHT22 is used to detect the humidity and the temperature. Next is GP2Y dust sensor. This sensor is used to detect the house dust, cigarette smoke, etc., and designed as a sensor for automatic running of application like air purifier and air conditioner. This is our circuit diagram. Next, last, the conclusion and the working part will be explained by the Vibod.
So I'll be explaining the implementation part of this project. We have implemented the website on React.js. This is the dashboard to our website. We have used mainly three cloud services, out of which we have taken real-time database and Firebase functions from Google Firebase. We've also taken EC2 instance from AWS. Going to the dashboard, this is the air quality monitoring system dashboard. It has location and location details at the top right corner. At the dashboard, we can select multiple graphs and we can view all the data in a graphical manner. This is all the data what we can see. There's an option to check the location on Google Maps. So this shows the current location. There's an option to generate a report as well. We can select a particular date, and then I can click on the view option. A table will be generated. Option to close down certain columns is also enabled, and when I click on see graph, I can also simultaneously view the graph for the above data. There's an option to print the data as well. It will be printed on paper, and then this is all for the implementation part. I'll show the cloud demonstration. The data that is sent from Arduino goes directly to our Firebase functions. The data is then processed in the Firebase functions, and then it is stored up in our real-time database. This is a NoSQL database. So the maximum depth at which we are handling the nodes is somewhere around 3 or 4. We have also set up a trigger at which after breaching a certain level of gases, an email is sent, and SMS is also sent through Twilio SMS API. And coming to AWS EC2, so we have deployed the front end of this website, this dashboard that we can see on AWS EC2. What we have done is we have containerized the front end using Docker. Then we have deployed the Docker image to Docker Hub. Then we pulled the image to the EC2 instance, and then we are running the Docker image on the EC2 instance. So on starting the instance, a public IP will be displayed, and then it takes me to this dashboard and I can operate it. Thank you.